Good morning. So we're going to go ahead and cover multiplying polynomials. This will be part 2. I guess that's how I'll label it. This will be now binomials, and then binomials, trinomials, but now we're going to go ahead and FOIL. Okay, so here we go. This is my cat, Soda Pop. All right, here we go. Okay, multiplying polynomials, part 2. Find the products of a binomial and a binomial, and you recall foiling, F-O-I-L, first outer, inner, last. So we'll go ahead and reference that as we get started. So here you have two binomials, x plus 2 and then x minus 7. Okay, now I will solve it where you're going to FOIL, like multiply. Remember, foiling or multiplying polynomials is just repetitive multiplication. That's it. It's repetitive distributive property. So I multiply, 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 multiply. And then, of course, I'll show you the box method. These are both equally preferred, so you choose, okay? All right, so first step, I'm going to take this x, and I'm going to highlight it pink, and then I'll highlight the product that I get from that multiplication. Okay, so x times x, right? Because so remember, you have to take every term in the first binomial and multiply it to every term in the second binomial. So x times x is x squared, right? Because x to the 1, x to the 1, 1 plus 1 is 2. Okay, so now go ahead to the second. X times negative 7, x, right? Okay, so we finished with the x term. So now we're going to go ahead and take the positive 2. So now I'm going to go ahead and multiply positive 2 times this x and positive 2 times this negative 7. So it needs to get multiplied into every term in the second binomial. So positive 2 times x is plus 2x. Positive 2 times negative 7, negative 14. And so now you have your 4 terms, and as usual, you're going to go, she walks wherever she wants. You're going to go ahead and, let me put I put my pen away. You're going to go ahead and combine like terms. So if you notice, these two are both x terms, negative 7x and positive 2x. So x squared minus 5x minus 14, and there is your answer. And remember, you want it in standard form. So x to the 2, x to the 1. This is really x to the 0, but it's just called, referred to as the constant, right? So 1x squared minus 5x minus 14, that's your answer. Okay, box method. You're given x plus 2 and x minus 7. Where you want to put the x plus 2 and x minus 7, that part, it doesn't matter. Okay, so x plus 2, so each space is a term from that binomial. And then, of course, the squares, in this case we have 4 squares because a bi times a bi, right? A binomial times a binomial, right? Binomial is 2 terms, binomial is 2 terms, 2 times 2 is 4, so we're going to end up with 4 terms if you performed your distribution correctly, okay, or you FOILed correctly. You're going to end up with 4 terms, 1, 2, 3, 4. So I have 4 squares here. Okay, the box method is very useful if you have a tendency to accidentally leave a term out or forget to multiply. This is just a good check, okay? X times x, right? So this cell is going to be filled by the multiplication of the row and the column. Okay, so x times x, x squared. This cell or this square is a multiplication, right, of 2 times this x, so positive 2x. This square or cell is x times negative 7, negative 7x. And this square cell is positive 2 times negative 7, negative 14. Okay, so there's your 4 terms, right? Okay, typically then, your diagonals are your like terms. Now I only have one diagonal here, right? Because it's tiny. Okay, so I get x squared, negative 7 plus 2x is minus 5x, and this is negative 14. And there's your standard form, and you get the same answers, and so you decide your preference. Okay, so here we are. We're going to go ahead and FOIL, so pink marker. So I have this a, I'm going to multiply it, right, into both terms in the second binomial or second polynomial. Okay, so you should get a squared, because a times a is a squared. A times 5 is positive 5a. Next, this positive 9, multiply, correct? So positive 9 times a is plus 9a. Positive 9 plus 5, positive 45. And now you have your combined like terms. Remember, this is a by times a by, so 2 times 2 is 4, and I have 4 terms. So a squared plus 14a plus 45 is my standard form, right? Perfect. Okay, box method. A plus 9, a plus 5, and again, it doesn't matter if you wanted to put a plus 9 here and a plus 5 here. It's like neither, right? It doesn't matter. Okay, a squared plus 9a plus 5a plus 45, right? 8 times a is a squared, 9 times a is 9a, 8 times 5 is 5a, 9 times 5 is 45, and again, your like terms are the diagonal. So you have exactly the same answer that we got earlier. So a squared, 14a plus 45. Yeah. Okay, here we're just going to be messing with negatives, but also equivalents. Okay. M minus 7, M minus 7. What happens if they are identical? Like here they were not, here they weren't identical, but here they are. It is equivalent to writing it as just M minus 7 squared. You know, in mathematics, we love to abbreviate. And so since they are identical, right, it's really like a 1 and a 1, and 1 plus 1 is 2. So these are equivalent. Okay, all right. Oh, I got a FOIL. So FOIL, right, multiply, I get m squared minus 7m, right? And then I get negative 7 multiply minus 7m plus 49, and then go ahead and combine like terms. And there you are. And so same thing here, box method, m minus 7, m minus 7. And these videos will be long like this, especially as we move on through this class. I'm just trying to make sure I don't make a mistake here. Because I go over reference or pass recall, or just to try and get the information, because you know you're not here to raise your hand and ask a question or have me clarify. So I try my best to try and get everything that I can think of that you could ask or would ask. Why did I put 45? See, look, what is that? Are you screaming in the phone right now? Oh my God. I was looking up at that. If you were screaming in the phone, like she totally did it wrong. Sad. Okay, fixed. Yeah, at least I did it right there. Okay. Okay. So some of the videos will be long and they'll be cut into like one example will be one video and another example will be the other video. Just because they're going to run like 40 minutes. But this is later when we start graphing. Okay, I'm just trying to cover all cases. Okay, so here, what happens if your binomials have two separate variables? So 3x plus 4y, x plus y. All right, you always want to make sure it's alphabetical. So we'll get to that part when I get there. This is what I mean. All right, so 3x multiply times x multiply times y, right? Okay, so 3x times x is 3x squared. 3x times y is 3xy. So you follow the alphabet, right? U, V, W, X, Y, Z. Okay, so follow the alphabet, how you write it. Okay, so plus 4y, multiply. Okay, so here's also where I mean. 4y times x. You're not going to write 4yx. It's not that it's wrong, it's just not ideal. You're not going to get marked incorrect for that. Now, if you're taking an Edulastic quiz, that it will mark you wrong, but then I go back and I assign you points, but it's 4xy, always alphabetical. And then 4y times 4y times y is 4y squared. Okay, so you're going to go ahead and combine like terms, right? X squared plus 7xy plus 4y squared. And there's your standard form, right? Okay, and same thing, box method, just for those of you that really like the box method. Let's just get that written out. So sorry, it's already 11 minutes long, but again, you're not here to ask questions, so I'm trying to figure this out. Right? And remember your diagonals, right? Those are your like terms. There will be some cases where it's not the case, so I will definitely refer to them as we get there. Okay, so here's your answer, and they are the same. Yes. Okay, so then last problem, I swear. Okay, find the product of a binomial times a trinomial. So we need 3 colors now. So what happens is then you're just gonna repetitive distribute just that many more times. So listen really quick, this is a binomial, a bi is 2. This is a trinomial, a tri is 3, 2 times 3 is 6. If you did this correctly, you should end up with 6 terms prior to you combining like terms, right? So that's why here on my box method, I'm gonna have 6 boxes. Okay, so let me just fill this out really quick. So this would be 3x plus 5, and this would be my 2x squared minus 8x minus 1. I'll just do this one first, this method first. And then each square or each cell is a product of the row and the column, right? So this would be 6x cubed, right? Because this is a 2, that's a 1. 1 plus 2. And if it makes you more comfortable writing in the 1, write the 1. So 2 plus 1 is 3. Okay, next. Negative 24x squared, 1, 1, 2. Minus 3x. I'm trying to make sure I don't mess up. Plus 10x squared, right? 5 times 2, x squared. Minus 40x. Minus 5. And now again, your like terms are your diagonals. Going. Okay, so now if I go ahead and combine those like terms, 6x cubed, right, because that's a loner. Okay, what's negative 24 plus 10? Negative 14x squared. Negative 40 minus 3 is negative 43x, right? If they have the same sign, add and keep the sign. Minus 5, and there is my standard form. So if you prefer this method, perfect. Okay, for those of you on this one, you would 3x multiply, right? Every term in the first polynomial must multiply to each term in the second polynomial, each term, okay, not just the front one. So 6x cubed minus 24x minus 3x. So 3 times 2 is 6, 1, 2 is 3. 3 times negative 8 is negative 24, x, 2. 3 times negative 1, negative 3, x, no x, x. Okay. Okay, so then let's go ahead and take the second one. Positive 5. Multiply. Now we could even vertically stack it if you like the vertical format. So positive 5, 2 is 10x squared. Positive 5, negative 8 is negative 40x. Positive 5, negative 1, negative 5. And so you have it vertically stacked, and now you can just go ahead and combine downward. Okay, so 6x cubed minus 14x squared minus 43x minus 5. Yes. By the way, your final's going to be you producing a video of you explaining something. And that's what the final was for the last quarantine class. And the kids kept saying, "Is that as easy as it looks?" Some girl sent in like 5 tries. Okay. Yes? Okay, so then I'll get the assignment up, right? Thank you. Bye.